In this question, we're given two sets of equations and asked to find the solution set of the variables. So the step-by-step method to solving simultaneous equation is number one, eliminating either the x or the y in one of the two equations. This means expressing the equation in terms of either x or y so that we get the value of a variable in terms of the other variable. So for example, if the equation is x minus y equals 4, and if you want to make y the subject of the equation, you can add y in both sides so that we receive x equals y plus 4. And then subtract 4 for both sides to obtain the value of y in terms of x, that is y equals x minus 4. And what this allows us to do is, since we have figured out y would equal this much in x value, we can substitute y value in the other quadratic equation, which leads to step 2, and that is forming the quadratic equation in terms of x or y. We already know that y would equal x minus 4 from our first step earlier, and the second equation states that y is equal to x squared minus 6x plus 2. This will enable us to substitute the y value represented in x in the second equation, and we will get something like this. X minus 4 is equal to x squared minus 6x plus 2. We can then send all the variables to one side to get x squared minus 7x plus 6 equals 0. And we're done with step 2. This equation might seem familiar to most of you now because you have been factoring for years, and this is actually the third step. So solving the quadratic equations to get one of the two variables. In this case, if you factor x squared minus 7x plus 6 equals 0, you will get x minus 1 times x minus 6 equals 0. Since one of the two product values would have to be a 0 to obtain a final value of 0, we can assume either x minus 1 is 0 or x minus 6 is 0. And therefore, x could be 1 or x could be 6. This leads us to our fourth and final step, finding the corresponding value of the other variable for each values of the variable we just solved. We can do this by substituting the possible x values in one of the two equations. So if we substitute the first x value of 1 in the first equation, it would be 1 minus y equals 4. And we'll get the y value of minus 3. Likewise, if we substitute the second x value of 6 in the first equation, it would be 6 minus y equals 4. And we would get the second y value of 2. To express these values in a solution set, you just have to write it like this. Since the x value of 1 would give a y value of minus 3, we write them together in the same element of the set as 1 minus 3. And the same goes to the second x and y value, which would be 6 and 4. And there you have it. We have learned to solve simultaneous equations systematically.